Good morning, class. Yoda is here. No, okay, okay. All right. Okay. Good morning, Mr. Bean. Hey. Good morning, class. Mr. Bean here. We're with the A3 AP Physics class, and today we're going to be discussing the range equation and how to get it, and how to derive it, and discuss its implications. All right. So what we got here is suppose we have a flat horizontal surface. Okay, kind of like this here, and we have some projectile. We'll go ahead and put it right here, and it's going to be launched at some angle. Okay, we do a vector here, and it's going to have launch at some angle, and it'll have some initial velocity VO, which we do not know what it is, and there will be some initial angle here, theta. Okay. All right. So in this problem here, we are okay. So it's here, and this projectile is going to take this path right here. Okay, kind of like this. Okay, and it's going to land over here as well. Okay, and so this here, this distance from here to here is called the range. Normally we associate that with delta x, but we will go ahead and make sure that equals r. Okay, and equals the range. So this is called the range equation. Okay, all right. So we have VO and we have theta. Uh, uh, we have no time. Okay, so there's no time given. Okay, now since it's being launched upward, we should know that the value of g, okay, is going to be negative 9.8. Okay, meters per second squared. So in our frame of reference, going down will be negative, and going up is positive. All right, so this is kind of the initial setup here. And so we'll go and take a look here and see what we got going on. So before we start here, normally we would ask to, usually step one in any projectile motion problem is to figure out what the x and y coordinates are for velocity. So normally we would say that Vox is equal to VO, right? And here we have what cosine of theta, okay? And we also have VOY is equal to VO sine of theta, okay? All right, so we always start off with this, okay? Now, some other things that might help out is we also know, now we'll also assume there's no air resistance, no air, okay? We're in a vacuum, so no air resistance. Make this R here. Okay, so here we know that delta X is going to equal VOX times the time, right? Flight time. Okay, from here to here would be the flight time. Okay, and we also know that delta Y is equal to, let's see, we got here. We have what VOY times the flight time, right? Now it's going to be minus 1/2 G T squared. Okay. And it's negative here because our frame of reference going down is negative. So G is negative. So I kind of move it out here, put the negative sign out here. All right. So this is our initial parameters. Okay. And we have here no time is given. Okay. All right. So let me go ahead and kind of ask the class here. Since no time is given, what does that imply if I was going to do a mathematical substitution situation? Yeah. So I need to solve something for t and substitute, right? Okay. Well, first of all, okay, so let's take a look here. So good call. So let's go ahead and take a look at this. And so here I see t here, and I see t here and here. Okay. So let's kind of help us out a little bit. What's delta y going to be? Okay. Okay. Yeah. Y-O is what? 0 here, right? And what's y over here? Is also 0. So delta y is 0. Okay, so let's go ahead and let's go ahead and do that, right? So we're going to use this equation right here. We're going to put it right here, and we'll say that 0, right, is equal to what we have here, VO y t, right, minus 1/2, right, G T squared. Okay, So maybe that's our first step, is maybe put a 0 in for delta y. Okay, now Sam, okay, you were talking about getting rid of t. So what could I do in a substitution scenario to get rid of t? Well, can I maybe solve this for t? Yeah, yeah. So if I do that, what is t? T equals what? T would equal delta x, right? Yeah, well, yeah, divide by Vox. Okay, is that t? Okay, all right. So here I have t now. Okay, so this is why for some people calculus is hard, because people can't substitute, or trig is hard because you have to be able to do substitution. So can I substitute this into here and here? Yeah, let's go ahead and do that. So this is 0, right? Okay, equals. So here we're gonna have Voy. And I'm gonna go ahead and kind of like put like a bracket here, just so we're okay. It's just gonna be what, delta t, right? Oh, hold on, delta x. Delta x, and this is Vox. Gotta be careful, right? Okay. Minus, here we have 1/2, right? This is g. And let me do another bracket here. And I'm gonna put in here, was it delta x, right? Divided by Vox squared. Okay, all right. So are we kind of getting somewhere now? All right. Okay, so we did the substitution here. Uh, Sam, anything we should probably do here? Simplify this, or uh, okay? I don't like fractions. Do you like? Well, should we probably do this square here and take care of this? Okay. All right. So let's So at this point here is whatever your preference is. So this is going to be theta here, right? Okay. So here we have VOY, right? And here I have delta x divided by VOX. Okay. Okay. Minus. Okay. Now this is going to be G, right? Delta x squared divided by what? 2 VOX squared. All right. So we did that. Okay. And let's see here. I don't like fractions. Okay. I despise fractions. Okay. So can I do something to this right now to get rid of fractions? Maybe multiply everything by 2 Vox squared. Yeah. So we're going to multiply. So we'll say multiply by 2 Vox squared, right, over 1. Okay, both sides, everything. So I do that. Okay, now I should be able to stop now. I think you guys might be able to do this, but let's. So if I do that, what happens on top here? What do I get? I get 2, right? I get what? Vox, Voy, right? Delta x here, right? Okay, equals, right? Uh, and what happens over here? This is hold on, a minus. Hold on, let me get a minus sign right here. Okay, all right, back over here. So minus, if I do it over here, it's just what? It's just g, right? Delta x squared. Okay, all right. Is that what we got? Is that okay? Everyone's happy here? Okay. Happy face? Okay, good. Good, all right, good. Over here, happy face. Okay, okay. No sad faces yet? Okay. All right. So okay, here's an x squared, here's an x. Could I maybe divide everything by delta x? No? Well, yeah, I can well, let's just try that. Well, here, just do delta x here, right? All right. Okay. Divide everything by delta x. So let's okay, we're almost done. Believe it or not, this is coming to a close very quickly. So here's 2 Vox Voy, right? Minus, right? G delta x, right? Okay. All right. So okay, cancel. All right. This is delta x squared here, right? Okay. Yeah. All right. So can I bring this the other side here? I add both sides, right? Okay. So this is going to be G, right? Delta x is equal to 2 Vox Voy. Okay. All right. So now, okay, so I'm kind of sort of stuck. I have to do another substitution. Okay. All right. So this is VOX, this is VOY. Okay. Do I see VOX and VOY? No. Okay, right here. Okay, do I see that? Yeah, I do see it, right? Okay, well, can I make a substitution? Yeah. So I'm gonna where I see VOX, I'm gonna put this in there. Where I see VOY, I'm gonna put that in there. Okay. So okay, go ahead and do that. So this becomes a G, right? Delta. Yeah. So this point here, you can kind of. I think some people who are math savvy can kind of see where this is going. VO, right? This is gonna be cosine of theta. This is going to be VO sine of theta. Okay. All right. So let's kind of do some simplification here. G, right? Delta X here. Okay. I'm going to put VO squared out here real quick. And I'm going to have a 2 cosine of theta sine of theta. Okay. Those who have Thornburg, you can tell her, you can get excited. Hey, we use a double angle formula today. Okay, those who have not yet had trig or who are in trig, but your guys are not doing identities yet, there is a trig identity that says 2 sine of theta cosine of theta equals sine of 2 theta. This is where Mr. Dante made an astute observation that it is half of 90 is 45 is half of 90. Actually, this is why you have maximum angle, maximum range at 45 degrees. Because if this is 45 degrees, Dante, what's 2 times 45? 90. And what's sine of 90? 1. Yeah, maximum range. All right, so now, so I will make use of this substitution here, okay? And what happens is that I have G delta X here is equal to, this will be VO squared sine of 2 theta. All right, now we're getting there. And then finally, divide both sides by G, and we have delta X is equal to VO squared sine of 2 theta divided by G, which is the range equation. And let's put a big happy smiley face on that. Okay. All right. That's the range equation. So, Dante, you're on the hot seat here. So, you have no choice. It's an involuntary error. So, so the implication is that if 45 degrees, if I put 45 degrees in there and 2 times 45 would be sine of 90, right? Which is 1. And that would be the maximum range. Any other value, I would get a sine value of less than 1, which would be a short. Okay. All right. So that is the range equation. We'll post this YouTube on Google Classroom here, and also we'll post this also on Google Classroom as well. Okay, any questions? Okay, may the force be with you. Okay.